Hey, welcome back. How have you been, boys? In our last Proxmox video, we talked about installing Kubernetes on Proxmox. It took a few minutes for us to get it up and running, right? But that wasn't the full install of Kubernetes. That installed kubectl, which is the command line tool for us to manage Kubernetes. If we were to actually attempt to start up our cluster, we were getting some errors. In order to fully use Kubernetes, you're going to need more than kubectl. You're going to need a utility called kubeadmin. This video teaches you how to get kubeadmin installed and how to get your Kubernetes cluster spun up. I think getting the command line tool is a little bit different than getting the actual cluster ready. So we're going to do that real quick. Behind me is our Kubernetes host, and we are going to SSH to log into it and continue our configuration from there. Behind me, I SSH'd into the Debian Kubernetes host we created in our last video. And we're going to quickly run through the configuration to get Kubernetes spun up and running inside of our Proxmox cluster. This is going to be a single node install. And then if people are interested enough, I might go back and teach you how to make it multi-node. The very first thing you want to do is make sure swap is turned off on your virtual machine. So let's do a sudo swap off -a. We do sudo, then we can cat our etc fstab and take a quick look and make sure that we don't have a swap auto mount. Let's see, we have UID swap. All we have to do is comment that out. Go ahead and do a quick nano etc fstab and then comment out the option to enable swap. We then have to issue a quick reboot to confirm that swap is off before we proceed with the rest of this process. In the background, you'll notice that the virtual machine is already starting to reboot, so that should take a few minutes. You'll then want to issue a nano etc modules-load.d containerd.conf. And then we're going to pass two modules into this file to enable them. Those two modules are overlay and br-net filter. Basically, what we're trying to do is enable bridging on this virtual machine for our Kubernetes cluster. We can then enable those two modules by using modprobe. So let's do a modprobe overlay and a modprobe br-net filter. We then also have to modify another file. That file is etc systemdcgroup.d 99 kubernetes k8.conf. What you want to do is enable some settings. Those settings are net.bridge.bridge-iptables equals 1, net IPv4 equals 1, and net.bridge.nf-call-iptables equals 1. So basically, we're enable bridging for IPv4, we're enabling forwarding for IPv4, and then we're enabling bridging for IPv6. You save and close. Once we've modified those two files, we can then install containerd. Before we start with the containerd install, we should probably take a snapshot of this virtual machine just in case we break anything. So I issue a quick snapshot. We give it a few seconds for it to create it. And now we are ready to install containerd. Installing containerd is easy. Installing containerd is as easy as doing an apt update and then an apt get install -y containerd. And we give it a few minutes to spin up. Containerd should now be installed. Next, we have to create a containerd config file. We can do that with a containerd. On the command line, you're going to want to issue containerd config. You'll want to issue containerd config default and then pipe that out to etc containerd config.toml. You then want to open that file that you just created with a nano etc containerd config.toml. And what you want to do inside of nano is find where it says SystemdCgroup. So if you hit Control W in nano, you can search. And then we want to search for systemd C. And you'll notice we now see SystemdCgroup listed here and it's set to false. You want to change that from false to true. And then we save it. After that, we just have to enable containerd. If we were to then run a sysctl status containerd, you'd see we now have our container listed there. With containerd now installed, we can go ahead and get Kubernetes installed, not just the kubeadmin, but the entire software suite. So let's do a sudo apt-get install -y kubelet kubeadm kubectl, and we give that a few minutes to run. Once the remaining Kubernetes utilities are installed, we then want to hold them to prevent them from being randomly updated on this host. So we can do an apt mark hold kubelet kubeadmin kubectl. And from now on, those applications will not be upgraded unless we remove that hold. Finally, we can initialize Kubernetes by using kubeadmin init. So let's do a quick kubeadm init. And then we pass through control plane endpoints. And we want the control plane to be the host name of this server. And you just give it a few moments and it is going to get the Kubernetes cluster up and running. And it looks like it's still spinning it up. In order to get kubectl fully running, we're going to need to create a config file. Making it is pretty straightforward. You do a make-dir -p home/.kube. Then you want to copy with sudo cp-i your etc kubernetes admin.conf folder to the home folder we just made earlier and call it config. We want to change the owner on that to our current user. So you do id-u id-g, and then you pass it to home.kube config. After that, you should be able to run a kubectl get nodes, and there we go. We now have Kubernetes up and running. We're going to want to do a couple more steps though, especially since right now we only have one node in our Kubernetes cluster according to this get nodes command. First, we have to check the taints inside of our Kubernetes cluster. When you spin up a Kubernetes cluster with only one node, the master node is tainted or marked as not available to run pods. To get around that, first you have to check the status just to be sure that taint is enabled. You can do that with kubectl get nodes-o JSON and then grep for node role, and you should get this output. If you see this node role key pair actually filled with data, your master node is tainted. To remove the taint, we do a kubectl taint node, and then we enter our node name, which is deb kubernetes. And then you can just copy this node role io kubernetes.io control plane option from here and paste it without the quotes, and then add colon, no schedule, and then mark or minus. Notice that we add that minus sign at the end. What that should do is remove the taint on the master node. And it helps if you also spell things correctly. And note that the node is now untainted. If we were to go back and run the get nodes-o JSON command again, our field is now empty when we compare it to what we had up here, meaning we should now be able to run this node. So how do we verify our Kubernetes cluster is running? Well, if we do kubectl get pods-n kube system, you can see we now have our Kubernetes pods running on this node. And that is it, boys. That is how you get Kubernetes up and running on a Proxmox cluster. If you enjoyed this content, please go ahead and hit the like button. If you'd like to see more, please subscribe. If you'd like to see more, please subscribe. Otherwise, stay blessed and stay tuned in for the next couple of videos where we'll go through deploying a image to our newly spun up Kubernetes cluster, as well as cloning this Kubernetes cluster, as well as spinning up 2 additional nodes, adding them to the cluster, and seeing what happens when we start breaking stuff. Peace, boys.